Okay, so this is the last part of our friction review for Physics 12. So, okay, so this is a question that I think we have mentioned a little bit like last day too. So it's a question where I'm trying to push a book on a wall and try to, get the book to stay there, but I'm only pushing from horizontal direction. So in this question, the textbook is 1.12 kilogram. So so what I'm thinking is, I'm just standing here, and that's Mr. Chung, and this is my hand pushing the wall, and this is my other hand. Okay, so I'm pushing the book, which is why it's staying on the wall. So if I look at the free body diagram of this situation, I have my pi force on the right, pointing toward the wall because I'm pushing it with my hand to the right. And then there's force of gravity. Now these two are the obvious one. So one is less obvious then, right? Is where's normal force in this case? Okay, so now remember normal force is always perpendicular to the surface. Now in this case, the surface is the wall. So therefore, normal force is perpendicular to the surface, which means it's actually pointing back at me. That is also Newton's third law, right? Action, reaction, force. So the normal force is a reaction to my action, which is the pi force. So then in this picture, we are still missing something though, because if this picture is now complete, then there's no way that the book won't fall down, because then gravity has no opponents, right? No one is fighting gravity. So that's not going to work. So something has to be fighting gravity. Well, luckily, we have surface friction. So this friction is pointing up this time. So it's the friction between the wall and the book, right? It's the friction on this red highlighted surfaces in here because of the imperfection that we mentioned earlier, right? So there's a friction preventing the book from falling down. Okay, so now if I want the book to be there, just stay there, then I want all of these forces to cancel everything. Vertical cancel vertical, horizontal cancel horizontal. So I have friction, I have gravity, they should cancel. Right? So let me circle them in pairs. So I have friction and gravity. They better be canceling. And I also have normal force and a pi force. They better be canceling. If everything cancels out, then we are good. So right now, then we look at, okay, so what do we have right now? Right? So we're looking for a pi force. So that's the big question mark in here. So that's the pi force. So to get the pi force, what do we need? We will need normal force, right? But if I don't have a pi force, how could I have a normal force? They're like opposite to each other, right? So we are looking for another way to find normal force then. So in this case, what we need is to get the only thing we could get right now, which is gravity. So let's start this question by drawing gravity. Okay, so let's see. So gravity, let's try to get that. So gravity is equal to mg, which is equal to, well, you have a 1.12 kilogram book multiplied by 9.8, and that's going to give you 10.98 Newton. Okay, so I have this question already done in previous classes, so that's why I'm able to write down the answer really quickly. But you can slow it down, or you can stop at any point, right? And actually try the calculation on your own if you're watching this at home. So, but I know that gravity. Okay, so now we go back to the picture. Look at the picture. Gravity is the only force that points down. Friction is the only force that points up. Well, therefore, I have this statement to make. In the y direction, friction has to be the same as gravity this time, which means friction is also 10.98. Cool. Okay, so friction is also 10.98. All right. Now I do realize that in, for example, in this question, I'm actually missing, well, actually, I'm not. So I'm not missing information. I thought I don't have the coefficient, but that is right there. So there is a coefficient of friction right here for us. Okay, so we also know this. So now we are looking at the x direction. So y direction, we have everything done. We have gravity done. We have normal force. We have friction done. They are in horizontal direction, and that's all done. Nothing else we can do in the in the x direction. Now we can get normal force. Now the way to get normal force is by looking at the equation for friction. Friction is equal to mu Fn, and we got friction. So to get Fn, we just take friction and divide it by mu. So we can do that because we have the 10.8, 10.98, and we have mu 0.465. So if we do that, we can get normal force, which is roughly 23.6. Okay, so this is the normal force portion. Now, once we have normal force and we go back to the picture, I think the question is already answered. Look at it. If normal force is 23.6 Newton, how much is your pi force? 3, 2, 1. Your pi force should be at least 23.6 Newton, right? Because if they don't balance, the book is going to move. So they have to be at least balanced. Now, of course, you can apply even stronger pi force, and the book will still stay there. But at a minimum, it has to be 23.6. So in this question, right, what happens if you apply, let's say, a 30 Newton pi force? Well, then you have a 30 Newton normal force as a reaction. Then that normal force is going to generate a even stronger friction, stronger than 10.98, maybe 12, maybe 13, 15, 20. But remember, friction does not make you move. Your friction can only stop you or slow you down. So even if your friction, maximum friction going up is 30 Newton, it doesn't matter. Your gravity is not winning, so the whole thing stay there. Okay, so that concludes our question at the end. So therefore, a pi force should just equal to normal force according to the free body diagram, which is about 23.6 Newton. And that's it. Okay, so that is all of this question that you have to consider. So it's actually a pretty easy question at the end. Now, from your worksheet from last day, right, from day 1, that worksheet is, I have some numbering error. So that worksheet number 1 is more like the last day stuff plus 2 day stuff. So maybe you didn't get some of the questions from last worksheet, the worksheet number 1. Well, that's because maybe we haven't reviewed friction yet. Okay, but if you did, worksheet 1 completely already, that's good. So even though this is day 2, the homework is still just, finishing worksheet 1 for this one. All right. Okay, so I'll pause the video in here and see you in the next section.